Well, good morning, everybody. Thank you for joining us this morning. My name is Karina Lepp, and I work with the Manitoba canola growers based out of Rivers, Manitoba, and we're really happy that you could all join us here this morning for our webinar, Preparing for Battle, Fighting Flea Beetles and Establishing a Strong Plant Stand. Just a couple housekeeping items for this morning's webinar. If you have any questions, you can type them in the bottom. You'll see the Q&A icon at the bottom of the screen. And there's also a chat function. And so just to welcome everybody here this morning, if you'd like to type in where you're joining us from, we'd love to see where our folks are from. So I think we'll get started right away. I'm really pleased to introduce our moderator this morning. His name is Jay Whetter. Welcome, Jay, with the Canola Council, and he's the editor of the Canola Digest. So we have a great lineup of speakers this morning, and we look forward to learning lots about flea beetles.
Good. Thanks, Karina. Yeah, let's get right into it. There's not much more that I have to add except to start just with a quick little summary, I guess, from Keith Gabert, who will be speaking later. And he said, I asked him what we want people to get out of this. And so the bottom line is beware the potential damage from flea beetles, and in a word, scout. So that's from Keith. So John Gavloski, our first speaker, he's an entomologist with Manitoba Agriculture and Resource Development. He's based out of Carman. And he provides information on insects, both beneficial and potential pests, obviously flea beetles included. And just personally, John has been a great help for Canola Watch content over the years. He's always willing to take a call and answer some technical questions. So John is, he's going to kick us off first of 5. And John, if you're ready to roll, go for it.
Okay. Okay, I'll assume everyone can see my screen. So what I'm going to provide this morning is a bit of an introduction to flea beetles. I'm going to go over different species that we've got, their life cycle, and the way they do feeding damage. That's what I'll be focusing on mainly. So to begin with, by the way, anything I've got in red on my screen, that's the really important stuff. So that is what I want you to pay attention to the most. I'm going to be quizzing you on the stuff in red later. So, and if you don't do a good job attending our crop diagnostic school, the next time we have it'll be mandatory. So pay attention to the red stuff. That's the important take-home message that I've got for you. So to begin with, species of flea beetles. When we talk about flea beetles, to most canola growers, we're talking 1 or 2 species that feed on canola, but there's actually a group or tribe of flea beetles that they're quite diverse. There's about 470 species in North America. In Manitoba, we've actually got about 72 species of flea beetles. So again, quite diverse. And my slides aren't advancing here. 1 second. There we go. So Manitoba, 72 species of flea beetles. And not all of them are bad flea beetles. There are some that are potential pests, a couple in canola, 1 in potatoes. Most flea beetles are kind of neutral. There are actually a few beneficial flea beetles in the prairies. In fact, there's been several species of flea beetles that have been released purposely to control leafy spurge because their larvae do a great job feeding on the roots. They feed on the upper parts, and they are a great biocontrol. So there's bad flea beetles and there's good flea beetles. Of the 72 in Manitoba, 10 will feed on canola, and 2 are potential problems in our canola, really. The striped flea beetle and the crucifer flea beetle. Those are your 2 more problem flea beetles. They are a little different in their biology. I'll go over some of that. Striped flea beetle comes out a bit earlier than crucifer flea beetle. They're similar in many ways, but their life cycles are slightly different. Both of them are introduced species. So they were accidentally brought over. The striped flea beetle's been here a long time. There's reports of it from prior to the 1700s, so it's been here for a while. Crucifer flea beetle, first found in British Columbia in 1923, but by the late 30s, early 40s, it had spread well into and through the prairies and was becoming a major pest on cruciferous crops that were grown in the prairies. And I mentioned earlier that we do have some beneficial flea beetles. Here's the ones that feed on leafy spurge. So if you do see a lot of black flea beetles in your ditches and they're on some of the weeds, don't worry, those won't be the same ones that will invade your canola. They're the two species mainly that I showed you earlier, striped and crucifer. Now moving on to life cycle. When we, well, what you see for flea beetles is the adults, and you see them twice. And so it might be tempting to think we've got two cycles of them, but really it's one generation. You see the adults twice. They overwinter as adults. So you will see the adults usually from about mid-August until into October. That's when they will start getting underneath the leaf litter, overwintering. The exact same flea beetles are what come out in the spring and feed on your canola and do all the damage. In between, they're laying eggs, and you've got larvae feeding on the roots. I'll show you some pictures of that later. Now, those flea beetles that start coming out in the spring, there's been a few studies on what drives them and gets their cycle going. Generally, they will fly when the daily maximum temperature is above about 14 degrees, and they prefer to fly on calm days. So down here, I mentioned negatively correlated with average wind speed. That basically means they don't like it when it's windy. They will hunker down and stay put, but you get a calm day above about 14 in the spring, and that's when they will start moving about. And in fact, they've already been moving about this year a little bit. Some of the striped flea beetles have been out on some of the warmer days we've been having in the prairies, but still it's just a fraction of what's overwintered. Peak emergence of the crucifer flea beetle usually occurs near the end of May. This was based on research done in Alberta when the ground temperature reaches about 15. So that's when you're going to get your peak emergence. And we know observationally that late May, early June, that is when the flea beetles seem to be at their peak or their worst. Again, that's when the crucifer seems to be starting to dominate. Usually what happens is striped comes out first. And here in much of Manitoba, we see the striped anytime from, it could be mid to late April. They seem to start dying off a bit earlier. By about late May, it's becoming crucifer that's the dominant species, and they can be very abundant well into June. Now, the challenge you have as a canola grower is getting your plant to a more tolerant stage before the flea beetles can do too much damage. And what I have in red here is also bolded. So this is extremely important to take in. Slow emergence and early season growth will make canola more vulnerable to flea beetles. With the seed treatments you have on your canola, you've got 3 to, depending on the conditions, maybe 4 weeks of protection. I would bank on 3. If you're lucky, you might get a bit more. So you've got those 3 weeks. And that's from the time you seed, not the time you start seeing cotyledons above the ground. That's from the time you seed. You've got roughly 3 weeks of protection. Anything that slows down that early growth is going to make your crop more vulnerable. If you get a year where you seed, things germinate really quickly, you get through the cotyledon and first leaf stages really quickly, you may not have to worry about foliar spraying. But a lot of years aren't like that, whether it's frost, dry conditions, cool soil temperatures, could be other insects like cutworms that are helping to contribute to feeding. There's a lot of things that can really slow your crops down. And the research done here in Manitoba, it kind of looked at the stages that flea beetles were doing the most damage. And this is older research from the 80s. They determined that it was the cotyledon and first 2 leaf stages really that were the most susceptible. After that, things progressively start getting a bit more tolerant to the feeding. And what heavy feeding will do is it can cause delayed plant development, uneven height and maturity, reduce your seed yield, and raise the chlorophyll content of your seed. And just to wrap up the life cycle part of my talk, on the left are some striped flea beetle eggs. On the right are the larvae. Larvae live in the soil. They feed on roots. There's been a little bit of research on do they have any impact? And the research done so far suggests that it's really not an economic impact on your plant. So the current thinking is you really don't need to be concerned so much about the larvae. It's the adults that are going to cause you problems. And you will see the adults again in late summer. That will give you some clue as to what the population is like, but people have tried to correlate those late season populations to what we see in the spring, and it really isn't a great correlation. So you can use that as a guide. If you saw a lot last August and September, that tells you there's a lot of overwintering, but it's hard for us to make seed treatment recommendations sometimes, or predict what's going to happen the next season, because when people have tried to study it, it seems to be quite variable. So to wrap up in the last couple minutes here, I just want to go over some of the challenges we have in assessing the damage from flea beetles. So first of all, have a look at this. I'm going to give you about 10 to 15 seconds. What percent defoliation is this to the plant? The answer is 25%. I'm sure everybody said that. One of the tricky parts with flea beetles and trying to determine, okay, do we need to foliar spray or not, is you are being asked to assess flea beetle injury, which is a subjective thing. Our eyes are always drawn to the damage. So when you have 25%, if you have a close look, there's a lot of undamaged tissue here, but there's a lot of damage as well. Our eyes tend to be drawn to this damage. And so something like 25%, it's really easy to want to say 30, 40, 50%. And we did an experiment once at crop diagnostic school. We sent people out to assess damage on some leaves, and then later gave them a picture key to use. And generally their assessments went down when they used the picture keys. People tended to overrate. Again, your eyes are drawn to that damage. So there are picture keys available. You could try to find one to maybe help you out a bit. So something like this obviously wouldn't be significant damage. This is only 10%, so nothing to worry about here. Now the other trick we have, and this is some more severe damage here. This is about 50%. But what this doesn't account for is, if you look carefully, there's some damage on the petiole and on the stem here. And another tricky part to assessing flea beetle injury is we're only looking at the cotyledons with that 25%, but you've got damage to the stems and petioles. How do you factor that in? If it looks like the whole thing's going to die on you, then it's pretty much going to be 100%. But that does make it much trickier to make decisions based on flea beetles. And one last note, when you're trying to make those spray decisions, also factor in what are the conditions like. Can the plant possibly compensate well? Have they got good soil moisture? Is it dry? How are the plants doing? Try to factor that all into your decision making. And I see my 12 minutes are up, so maybe I'll end with that and turn it over to Jay.
Right on. Thanks, John. Well done. We do have a question in from Randy, but let's save all the questions because we're sticking with flea beetles throughout here. Autumn is going to talk more generally about stand establishment, but we'll get into a good discussion about some of these. But Randy has a really good question here. So yes, if you've got a question, use the Q&A and pop it in there. John, feel free to check that question and think about how you might answer it. And I think Alejandro, who is our next speaker, will also have some input on that answer as well. Anyway, yeah, so we're doing 12 minutes per speaker, 5 speakers, and then we'll have about 20 minutes to half an hour at the end for a good Q&A with everybody. Okay, so our next speaker is Alejandro Costamagna, who is an associate professor of entomology at the University of Manitoba. He works on sustainable methods to control insect pests in crops, and he's interested in how landscape complexity and natural enemies can be used to control pests. Obviously, he's doing work on flea beetles. That's why he's here. So he's going to talk today a bit about the shift in species And also that really key topic that he's working on are the landscape effects on flea beetle abundance, defoliation, and predators. Ale.
Hey, thank you very much, Jay, and thank you very much, everybody, to attend to this webinar. Can you hear me okay? And can you see the presentation before I start?
Yeah,
okay,
looks good.
Great, thank you very much. So first, I would like to introduce the people that work in these projects, of which I'm going to share some of the results. I'm fortunate to work with several great scientists, Jennifer Otani and Hector Carcamo from Alberta, Tyler Wist and Megan Bankowski from Saskatchewan, all of them in Canada. John Gavloski from Manitoba, he just talked before me. And then from the University of Manitoba, Rob Duncan, and two postdocs that work in my lab, Tarshi Nagalingan is no longer working with us. Now Maxime Damien is working in the project, and then a master student, Sheila Storosuk. And I'm going to show some work done in these two projects that we have with the Canola Council. So for this, we were fortunate to sample many fields in the prairies. And we thank you all the farmers that allow us to work in their fields. What we usually do is put 5 sticky traps for several weeks and assess the foliation. So we have sampled a number of fields across the years. This is just a summary of the first 3 years of work. We have more coming. And one of the things we notice is that among the two main species that John introduced, the stripe and the crucifer, there has been a shift in the composition of the flea beetle assemblage of pests in canola. So traditionally, for example, in Manitoba, we have the community dominated by crucifer flea beetles, 88 to 96%, and only a minor proportion of striped flea beetles. But now we found in our samples between 51 to 69%. Similar situation in Saskatchewan. Used to be kind of even in previous years. Now it's heavily shifted towards more striped flea beetles. And even in Lethbridge in Alberta, where Hector works, used to be dominated by crucifer flea beetle. And now we have up to a third of the samples composed of striped flea beetles. And the other region we work in Alberta near Beaver Lodge in the Peace River, it has been always dominated by striped flea beetle and continues to be so. So we have seen a relative recent shift in the composition of species with more striped flea beetle in there. The other thing we are really interested in is to see if we understand what type of variables and features of the landscape can help us to predict whether we'll have more abundance of flea beetles and more damage. So using this large data set that we have collected, we fit some statistical models to see what are the best predictors of the abundance of these flea beetles. And here are the results that we have so far. We're still tweaking the analysis and looking for some other variables. But what we have so far is that for crucifer flea beetle, the proportion of canola that are within a 2-kilometer radius is affecting their abundance. So the more canola you have, the less flea beetles we observe in the fields we sample. And that could be explained by some sort of dilution effect. If you have more canola, then you have less flea beetles in the fields you sample. But we'll see the story is a bit more complicated than that. The other important predictor is called edge density, and this is just a measure of the amount of field border that we have in the divided by the area of the landscape. So essentially, what it means is that if you have smaller fields, then this edge density is higher. So what we found is that in landscapes in which we have smaller fields of any crop, not just canola, smaller fields in general, we have a lower densities of flea beetles. Okay. In terms of what seems to be associated with higher densities of crucifer, higher proportion of grass borders seems to increase or be associated with an increase of crucifer flea beetle. And then we have a very weak but significant effect of the proportion of woodland within 0.5 kilometer. Now, to our surprise, seems to be different for striped flea beetle. These are very closely related species. They have very similar biology, similar effects, feed on the same plants, but yet they are responding very differently to the landscape around the same fields we sample. And for striped flea beetle, what we found is that the main things that drive their abundance are really the year at which we did sample, the region at which sample, even the week at which sample are significant factors affecting their abundance. And the only thing at the landscape we can find is an effect of the proportion of woodland within a ½ kilometer radius around the field. That seems to increase the abundance of striped flea beetle. So very different responses to the same variables. Now, when we look at defoliation, we have a different picture again. And defoliation is a product of both species. We can't distinguish whether defoliation was due to stripe or crucifer. And most of the time, we have them mixed in the fields. So it's a combination of both. So if you consider that, it's not a surprise that the actual defoliation seems to be influenced by slightly different factors. And what we found is that the defoliation is explained by the proportion of canola within a ½ kilometer radius. So the more canola, the more defoliation. So different than what happened with the abundance of crucifer. And also the size of the canola fields. So the size of canola fields, if they are bigger fields within a ½ kilometer radius, we observe higher damage on canola. For grass border, we have the opposite again as for the abundance in crucifer flea beetle. The more grass border within ½ kilometer, the lower the damage on the canola. And finally, we have a very weak, I would say, but significant explanatory factor as the abundance of striped flea beetle. So we were able to relate defoliation with the abundance of stripe, but not crucifer, which I think it's interesting. We're still working with this analysis, and we're not so sure what conclusions we can make, but this is what we have so far. So there's more to come for this. The other factors or the other studies I want to share with you very quickly are done by Shayla in the lab, and it's another thing we're really interested to see what kind of natural enemies consume flea beetles. And here you have a picture of the usual beneficials that we found in the field. These are ground predators, and just to give you an idea, the pictures are bigger than in real life, as you can tell. So here's a flea beetle for you to compare. Some are fairly large. They're generally predators. And we also try, or Shayla tries, 3 of the common spiders we have in the fields. And she tried these using very simple experimental designs in the lab. So a petri dish with a small canola plant. We put 6 flea beetles there, 3 stripes, 3 crucifer, and 1 predator per petri dish of whatever species we can find in the growers' fields we sample. And we have controls without them. And as we can, and we found that they actually, indeed, some of them eat them. So here you have the pieces left of a couple of poor flea beetles that were consumed. So they're able to find them here. And here are the results of that. So out of the groups, we try a couple of ground predators, Harpalus and Theosticus, which are common ground beetles, reduce the number of flea beetles in the petri dishes after 2 days. So here we have a control with no predators. Most of them survive. And the ones with these 2 genera sustain mortality. And so did the ones with 2 of the 3 spiders we tried. So there's we show that these predators, under these rather artificial conditions, they're able to capture them and consume them very effectively. Okay, and some of the other predators were actually not very interested in them, according to our experiments. So we're going to follow up with this in more realistic arenas and see if we can correlate their abundance in the field with some mortality for flea beetles. And if we can advance. And the last thing I want to show is another experiment in which we are interested in seeing what affects stem damage that Sean showed before was another factor affecting the canola by these insects. So we did a simple experiment with a plant manipulating the number of plants to mimic different planting rates. So 6 canola plants or 12 canola plants against 6 flea beetles per cage. And we quantify both damage to the cotyledon and damage to the stem. So here you have a heavily damaged plant. And we did this at 2 temperatures, at 28 degrees constant and 18, to see if temperature affect the preference for feeding on the cotyledon versus the stem. And essentially what we found is that temperature affects them. There's way more feeding on the, so this is defoliation. There's way more feeding at 28 degrees than at 18 degrees. And it doesn't seem like at the plant densities that we use, with the number of flea beetles we use, there's a difference whether there were more or less plants. The damage was not very heavy. This is after 24 hours. And in terms of stem damage, we found pretty much the same. Higher stem damage at 28 than 18, and not really an increase due in plants or in pots that have half of the plants than in pots that have high densities. So we are still looking into this. We will probably try a lower temperature to see whether we see differences, but the damage is very, very small at low temperatures. So it's been hard to do that. At high temperatures, if we continue the experiment for more than 24 hours, then this is what happens. And in some cases, the plant dies and we can't estimate the stem damage. But so far, this is what we get. In conclusion, just to give some take-home points, we have seen a shift in the abundance of the striped flea beetle. Seems to be becoming the dominant species in a lot of areas. Despite their similar species, they respond to different features in the landscape and in a different way, the 2 species. We found more damage associated with more canola and bigger canola fields at ½ kilometer, and a weak association with the striped flea beetle abundance. We found at least 2 genera of ground beetles and 2 genera of spiders attacking flea beetles in lab conditions. And we found increased damage of the cotyledon and on the stem at higher temperature. So that's all I prepared for today. I'm not sure how I'm doing with time, but I'm happy to answer questions during the question period. Thank you.
Perfect, Ale. According to the very detailed schedule that Leanne gave me, you are right on time. She actually used 9:57. So perfect. Thank you. All right, we'll move on. Yes, so if you have questions for Ale, use the Q&A and enter them there, and we'll answer those when we get to the Q&A section at the end. Moving on to my colleague, Keith Gabert. So Keith works for the Canola Council of Canada. He's an agronomy specialist based out of central Alberta, and he leads the team on insects. We can't pull him away from those insects. He just loves them so much. In fact, he tells a story about when he was a kid, he would go out into the cabbage patches and he would hit the white butterflies with a shovel, and then he would put big dents in the cabbages, and his parents were mad. Anyway, so he's saying that he's pretty sure his technique has improved. And just so that we can make the cabbage connection, of course, anybody who's smelled a canola field knows that cabbages and canola are closely related and have many of the same pests. Anyway, Keith, what do you got for us?
Thanks for the introduction, Jay. I'm hoping you can see a video clip in front of you.
Yep.
Excellent, because these Zoom meetings, although we're tired of them, we still seem to need a little bit of practice to make sure it's right. So what you see in front of you is actually just a clip from our 1-minute segment on flea beetles, a video we put together last week. There's a whole selection of those, but obviously if you're attending this webinar, you're probably most likely interested in flea beetles. And it's a good, quick reminder of things to be concerned there. John and Alejandro have obviously already covered some pretty important things about flea beetles. So I'm just going to cover a couple slides and leave some more important things for Autumn and Larry to cover. So feel free to go back to our Canola Encyclopedia and the references material that we have on our site, because there's a lot of good information there. Sometimes we forget to go look at it. One thing that we haven't really addressed with John and Alejandro is that the most common control measure for flea beetles, and something that we've essentially put on every bag of seed, every blue seed that goes into the ground in Western Canada, is an insecticide seed treatment. So there's a lot of things that go in and around and on that blue seed, and there's a lot of things that you can do right and things that you have choices for. So if you've gone in to pick up seed this spring, you've probably ordered it back in October, and they asked you questions about what do you want for a seed treatment, and do you want the upgrade? Is there something that you're concerned about? I've highlighted here the insecticide portion. If we're talking about flea beetles, obviously we understand that there's a whole seedling disease complex that can set back our crop and cause us some problems on the disease side, but we're going to focus predominantly on insects and obviously on flea beetles. There's a number of different choices that you have on the market here now, and typically it varies by seed supplier. And it depends which company you're buying seed from and which agreement they've made with their seed treatment supplier, what your choices will be. But there tends to be two general streams. You'll find the Helix Vibrance on most of your Roundup Ready products. You'll see the Prosper Evergo on most of the Invigor BSF products because there's some strong connections with the chemistry development within those companies. And on top of that, you'll see some new entrants into the market. We've got Buteo, an upgraded flea beetle seed treatment that's available for the first time this year. We've got a group 28 insecticide, Lumiderm or Fortenza Advanced. It's marketed in the marketplace as well. And the one thing that I wanted to point out on the canola seed treatments is we've relied on neonic seed treatments for a decade and a half now. And it's been a real core for our flea beetle protection. Really good mammalian toxicity package, effective on the flea beetles, but it's been under a bit of pressure. So the Buteo as a 4D is different than the neonic in a 4. Sulfloxiflor from Syngenta is an additional treatment that enhances some flea beetle activity. So you could have 1, 2, 3, or probably even 4 different insecticides as an option in your seed treatment package coming into this spring. I added Saltro at the bottom only because it is part of the seed treatments. And I've got a few little pictures here to sort of talk about that. Saltro addition is for blackleg, so early season protection there. The group 28, while it does enhance flea beetle activity, does a really good job, particularly with some enhancement on striped flea beetles. It also adds, depending on the rate, cutworm protection. So if you've the best customer for those additional seed treatments tends to be growers that have had issues with cutworms in the past, because I can't predict flea beetles, but I definitely can't predict cutworms. So it's really hard to decide when you're going to need to upgrade these seed treatments and what you're going to need. But if you've had trouble with stand establishment in the past, chances are that you're going to think about putting a little more investment into protecting that seed moving into the future. You've seen this slide from John already. It's actually pretty hard to assess flea beetle feeding damage. I like to tell people that the best way to assess flea beetle feeding damage is to have somebody else do it. That slide that you had for John showing, I think it was 25% damage, you might as well have called it 90, because if it were your crop, we wouldn't need to talk to you about the action threshold being 25% or the economic injury threshold being 50. So that economic injury threshold means at what point will your crop actually suffer some damage that will impact your yield? And a canola crop can have a lot of feeding damage before that happens. I liked one of Alejandro's comments. He mentioned something about at increased temperatures, they couldn't really do the experiment because they ended up with just a dying stem as part of the results. And at really low temperatures and low flea beetle numbers, they really didn't see anything. So it's really, I like to say that flea beetles are a temperature driven engine, and a lot of factors can go into deciding how quickly you need to act. But that 25% action threshold is there because in really severe conditions, we can move from that 25% action threshold through to the 50% in as little as a day. And those thresholds are for the entire field. It's not just the one spot you stop at the gate, because sometimes we'll see a real influx of pests or damage there or poor stand. So it's something you have to do a good job scouting on, and recall that that 25% action threshold is really the point where I tell growers you should have some insecticide in the shed, or at least spoken for at your dealer, because if you need to spray, that decision might need to be made very quickly. I've mentioned that the action threshold and the economic threshold is 25 and 50% respectively. But one of the things we'd like you to point out is you want to look for new feeding. So the seed treatments that we have available really need to be consumed to have any effect on the insects. So you're going to have some feeding. Even under the most successful conditions for stand establishment, chances are you're going to have some pock marks. I've got a little red circle there indicating some relatively fresh feeding. And if you spend any amount of time out in the field, you'll be able to identify some old feeding. They tend to be a little dry around the edges. They often look crusty. Sometimes you'll see some leaf death near them as well. But it's fairly easy to distinguish between a nice clean edge that probably looks a little damp or wet still because it's still leaking from recent flea beetle feeding, from old flea beetle feeding that might have been there for a week or two. And we're not really worried about the week or two damage. We're worried about the 25 to 50%, and are the flea beetles actively feeding? So a couple things to consider that I've already talked about is general stand condition. Autumn will really get into that for us here as our next speaker. Feeding on new leaves. And I'd like you to assess stem feeding damage. Now, there is no threshold for stem feeding damage, so I'm happy to see that Alejandro is doing some of that work. But if your crop isn't looking better every second day or so as you're coming out to look at it, and chances are you're going to be scouting more frequently if you're starting to worry about flea beetle damage. If your crop isn't looking better, this is one of the things that you should have been scouting for already, or need to add to your scouting program, is perhaps you've had cool, windy conditions that really don't promote feeding on the upper leaf surfaces. And maybe they've hunkered down near the stem and they're chewing that plant off right at the bottom. And you're going to have to take a guess for what the threshold is there. But obviously a chewed off plant is 100%. And one bite you may be able to sort of overlook, but it's one of those things that you just add as another risk factor. Now, if you've made the decision to spray for flea beetles, or if actually the decision is, if your seed treatment isn't providing you enough protection and you've hit that 25%, it looks like you're going to be at 50 and you're concerned, there are a lot of foliar insecticide options. I really won't go over them. I've simply pulled this out of our provincial crop protection guides. The one thing that you'll need to be aware of is that depending on which seed treatment package you've got, which company you've sourced your seed from, there may in fact be some package options for graminicides, herbicides you're using, and insecticides. And even if those packages lower the cost of an insecticide option, it doesn't change the decision-making process of, do you need to spray? So the cost of this foliar insecticide really needs to include the environmental impact of removing all the beneficials or the things that you're taking over and managing yourself with a foliar insecticide option, because it's a pretty big hammer in terms of impact on the insect, beneficial or pests and otherwise that are in that field. And it's something we encourage growers to avoid until they need it. But here's a number of tools that are available and ready and waiting. And like I said, if you think you've got flea beetle issues, make sure that that insecticide is available, because one of the common things is it's not a product that's always stocked in the shed in large quantities. And if we start to see flea beetles, they will likely be based on a regional temperature and stand establishment issue. And you're going to see a bit of a run on it the first day or two until the companies get a handle on who needs what for product each spring. I'm going to hand it back over to you, Jay.
Hey, Keith, right on. Perfect timing. Good questions coming in. Thanks to everybody who's put one in there. All right, we're going to move on to Autumn, another Canola Council colleague of mine. And for a long time, Autumn was our plant establishment lead, and Autumn has helped create, or helped. Autumn has been the lead on this new crowdsourcing program we're going to try out this year called Canola Counts. And Autumn's going to talk about Canola Counts a bit, and in general about how establishing a good, strong, uniform stand can help with flea beetle management in particular, among other things. Autumn.
Hey, thanks, Jay. You guys are gonna have to bear with me today. I've got a 4-year-old and a 6-year-old, and the 4-year-old had a lot of big emotions this morning. So I've got a bit of PTSD right now. We're going to start with some poll questions, and Karina or Leanne is going to pop up the Zoom poll question. So the first one is going to be, how do you determine canola seeding rates? And you should see a poll pop up. Perfect. So your options are either you always calculate for each field using the canola calculator tool at canolacalculator.ca. You always calculate for each field using some other calculator. You sometimes calculate for each field using canolacalculator.ca. You sometimes calculate for each field using some other calculator. And then another option is you never calculate seeding rate. You're always using or recommending the same blanket pounds per acre rate. So we'll give it a couple more seconds. I know that was a little bit wordy, but looking forward to seeing what you guys say here. That's probably good for time. All right, so we've got about 28% using the canola calculator all the time, but 49% using another tool all the time. That's excellent. So the majority of people are calculating seeding rate. So high five to all of you guys. And still about 12% of you guys using a pounds per acre rate. So thanks for your honesty. The next question we're going to move on to, if my slides will advance, is how often do you calculate canola emergence? And that question should pop up here. Every canola field every year, sometimes or almost never. So how often do you calculate your canola emergence percentage? Every canola field every year, sometimes or almost never. This could be for your clients or for your own fields. We'll give a couple more seconds and then we'll get the results here. All right, 48% every canola field every year, awesome. 46% sometimes and 6% almost never. Awesome, well, we'll get into the presentation now. I just kind of like to start with some sort of audience interaction because I really miss having people around as I'm presenting from my basement office where I live these days. I'm going to talk about canola establishment this morning, and I kind of broke it down to a kind of a recipe for success. So the number one thing you need to be doing with canola plant establishment, target 5 to 8 uniform plants per square foot. You want to take care when you're seeding to maximize your emergence and uniformity. You'll want to evaluate each field and submit your data to canolacounts.ca, which Jay sort of introed a little bit, and I'll talk about in a slide in a little while. And then finally, and potentially most importantly, is that you make improvements. So after you do these first 3 steps, you should have a good picture of what establishment looks like on your farm or on your clients' fields, and you can help them or initiate your own improvements. So when it comes to targeting 5 to 8 uniform plants per square foot, it's kind of that range is set for a reason, and plant density is really about risk management. So will you see a yield impact going from 5 plants per square foot to 8 plants per square foot? No, you won't. And even in around that 3-4 plants per square foot is where you'll see that yield stability and predictability drop off. But really, plant density is about risk management, less than yield, and how comfortable you are with risk. Canola seed is a big investment. It is a high value investment and a high value input. And it's important that we remember that seed cost is not our total cost of production. Although that's a big bill right at the beginning of the season, we know that fewer plants are going to mean slower canopy closure and later maturity. That will impact flea beetles. If you have fewer canola plants for them to feed on, then that damage can be more significant. Also, you can't afford to lose any plants to them. Weeds will have more space to grow in a lower plant density. And also this picture here I took in 2019 when we had a really early snow in my territory, but this is a pretty common story across the prairies in recent years. And one thing you can do to impact your maturity is choose an earlier maturing variety, but also another thing would be to bump up that plant density to that 7 to 8 plants per square foot range. We know that more plants equal faster canopy closure, so more competition with weeds and earlier maturity, as I said. And with more plants, any plant loss is a lot less impactful. You'll also have better integrated weed management. So a few years ago, when we switched a recommendation from 7 to 10 plants per square foot to 5 to 8 plants per square foot, the biggest pushback we got was from the weed scientists, who are really concerned that we're already pushing to thinner plant stands, and we're already having more and more people do 2 herbicide applications, and we're having issues with herbicide resistant weeds. So plant density is a lot more than seed cost and yield. It's really about integrated management and risk management. So you'll want to use the canolacalculator.ca to set seeding rates for each field to hit that plant density. I'm going to try out a video here and I really hope it works, but this is going to the canolacalculator.ca. Click on the seeding rate calculator. You'll enter your 1,000 seed weight, your target plant density, your estimated emergence, and then it'll spit out up here your pounds per acre seeding rate. You can enter your seed cost. I just put it to 13 pounds for this video, and that'll show you how much your seed costs per acre. Try it again with a 6-gram seed lot, 6 plants per square foot, 60% emergence, that's staying the same. Now you've got to seed 5.8 pounds per acre to hit that 6 plant target. So it looks like a lot of you guys on the webinar are already looking at your 1,000 seed weight when you're setting seeding rates. So I think that's a really good thing. And I really urge you to check out the seeding rate calculator and also the other calculators on canolacalculator.ca. Oh, what does this funny thing? Okay. Next would be taking care when seeding or planting. Really, the whole purpose of seeding or planting canola is to maximize emergence and uniformity. So always have that in the back of your mind when you're seeding or when you're out helping your customers. Wherever possible, seed into warm, moist soils. So at least 5 degrees Celsius. I'm going to have a slide near the end talking about chasing moisture because I know that's a big topic this year. But while seeding, you know, if you're running the drill, stop as often as you can. Check your seed fertilizer placement and separation. Make sure you're stopping to calibrate at least once in every field. And every time you stop to check placement. Go out, dig some rows side by side so you can see what your placement is from front to back of the drill. And also remember that that the only safe seed place fertilizer really is phosphorus. It's the only thing that needs to be in the seed row. You want to max that at 20 pounds, and you want to be really careful with that. Next, you want to evaluate each field. So as these little seedlings are coming up out of the ground, this picture here is a little bit early for a final stand count. It's about 2 leaves. So you could wait a little bit later, even after herbicide timing. Really, when you're counting plants, you want to check at least 5 unique spots and calculate an average for each field. Volunteers like this one here between the seed rows do not count in your emergence calculation and your density counts. I've got a hoop in this picture. I like using hoops because they bounce. Also, in the past year, I haven't had much for childcare, especially last summer. So my kids would come along with me a lot, and getting your kids throwing hoops and counting is a good thing to entertain them and keep them from fighting too much when they're in the field with you. Making a plant count hoop is super easy. It's basic geometry, which is also, you know, if anyone's got kids home on quarantine, you can make them, try and get them to make some hoops for you. I use a 1/4 meter squared hoop, which is 56 centimeters in diameter, 177 centimeters circumference. You could use an imperial hoop, so you could use a 2 square foot hoop and then just divide by 2 to get your numbers per square foot. And that's 49 centimeter diameter, 153 centimeters circumference. You're welcome to take a screenshot of this, or you can visit the Canola Encyclopedia, and these calculations are here as well. You can use meter sticks, and there's a calculation based on row spacing to see your plants per meter or per unit area there as well. And that's what most researchers do. Like I said, I just like the hoops because I throw them and they bounce somewhere that I might not automatically be drawn to. You'll use your plant densities, your average densities from each field to calculate your emergence percentage. So I'm going to talk briefly now about the Canola Counts survey. I started this maybe about a year ago. COVID sort of delayed things with development last year. But what we're trying to do is to crowdsource plant establishment data. So historically, we would mine some data from the Ag Canada Weed Survey, which was in each province every 5 years. But we didn't really have a way beyond anecdotes to track, like an organized way to track canola emergence and density across the prairies every year. So we're going to be doing that. We're asking everybody to input their canola counts at canolacounts.ca. You'll go into the field at 2 to 4 leaf, so 2 leaf to 4 leaf here. There's also an option for fall stand counts, which are also important to do. And this is going to help us collect annual establishment data. So we can track progress towards our industry production goals. And with any crowdsourcing project, more fields means stronger data. So the more that you guys can enter, the better. It'll help you and your customers identify strengths and challenges in your operation to plan for improvement. You can see how your fields measure up to regional averages. So once you submit a field, you'll get a kickback email right away. But then at the end of that counting season, so at the end of this spring in early July, you'll get an email with all the fields you entered, and then a map that will show you how you compare in density and emergence with your neighbors. Not your specific neighbors, this is blurred, so we're not going to be telling you exactly who's doing what, but it's kind of blurred, sort of like the insect forecast maps. We're also going to be giving away a load of prizes thanks to Alberta Canola, Sask Canola, and Manitoba Canola growers who funded the development of this project. We're going to have weekly weekly draws where we'll go through and randomly draw one of the fields that were entered that week, and you'll get a $50 gift card. Every week that'll be drawn, and then at the end of the season, the most fields that were entered by a person in each province will get a $100 gift card. So that's canolacounts.ca. If you have any questions about it, definitely reach out to me. But I'm really excited about it and hope we get lots of engagement this year. This is a quick little video about how it works. So this is going to canolacounts.ca. You'd enter your name, your email address, your farm name and field name are optional. This is if you're entering multiple fields or multiple customers. You can auto locate. I scrolled through pretty fast. You'd enter your plant density in square feet or square meters. You can calculate your emergence right through this tool. So enter your seeding rate and your 1,000 seed weight. It'll calculate your emergence. Then you enter your plant counts, or if they're spring or fall. And then you would want to check yes for receiving emails. That will give you access to the maps that I mentioned. And then yes to enter in the prize draws, unless you don't like prizes, which I guess fair enough and better for the people who do. But really looking forward to your engagement on it going forward. And then finally, the last thing in establishing a strong plant stand is making improvements. So the whole point of this exercise is to understand the strengths and challenges in the fields. And so some of the easy pickings, I guess, that I hope you already initiate this year, but you'll probably identify going forward, would be calibrating more often, checking seed and fertilizer placement and separation more. This seems like a really basic thing, but it's something that myself and my team get calls to every single year. Actually, one of my colleagues a couple of years ago got called to a field where someone had a new drill, went out and seeded like 2,000 acres with it, or 2,300 acres, something like that. And then when it was coming up, they noticed the field was really stripy. And what happened was the hoses for the fertilizer and the seed were backwards. So the seed was getting put down 2.5 inches deep, and the fertilizer was up in that 3/4 inch range. And so that's something that could have been perhaps avoided if placement and separation had been checked. So really watch out for that. You can optimize residue distribution at harvest, which is something you should be thinking about now for this spring or this fall. Optimize soil phosphorus long-term so that you have less of a need to push seed-placed phosphorus rates. This is a big one, and I encourage you even this spring as you're going out and seeding canola to shut your phos off, for 100 feet or something like that, and mark that spot or come back to it and see if you have better emergence there, because that fertilizer burn is pretty hard to diagnose. It's really just a thinner stand. And if you seed all your canola the same way, you might never notice that you're throwing away canola seeds. And then improve record keeping to avoid herbicide carryover issues. This one might be a big deal this year with how dry it was in a lot of the prairies last late summer, fall, and then going into this spring. So those are all practices. Those are all things that aren't really going to cost you very much money or any money, mostly time. There are also things that you can buy to try and make some improvements in your operations. So you can maintain or replace worn equipment for placing seeds, openers, hoses, manifolds, potentially the whole unit, but you don't need to buy the newest, biggest, fanciest seeder to have or planter to get the best establishment. There's a lot of practices you can do. And then you could also maintain and replace residue distribution systems. This is a picture my colleague Ian took this week. Actually, he's replacing some openers on his drill at home. This is one of his old worn ones, and this is a brand new one, and he's pretty excited to get the new ones on there. Okay, so the question that I've been asked and heard argued about a lot this year, should I chase moisture? I live in Lethbridge, Alberta, which is kind of our driest area in the prairies. We have had, 2017, 18, and 19 were extremely dry years. There were parts of my territory that saw an inch of moisture all summer. for a number of those years. So I'm a little bit well versed in what's happening in the dry conditions, and we argue about this, chasing moisture in my territory, every spring. And the big question is, how far down is it to moisture? Have you been looking at the maps and getting scared? Or have you been going out to every field and digging with a Dutch auger or a hand shovel and seeing exactly how far down that moisture is? And if you don't know the answer for every field of yours or a field you're advising a client on, then I really highly recommend that you get out there and look, because you might be surprised what you find. Next, most importantly, would be how accurately are you going to be placing, or is the grower going to be placing every seed? So if you're talking about chasing moisture down to 2 inches, how confident are you that that seeding implement that's going to be used is going to be placing every single seed at 2 inches? How many of them are going to be at 2.5? How many of them are going to be at 1.5? And what's that stand going to look like? Are you comfortable with putting that little seedling through that much stress to get up out of the ground, just to chase that moisture? And these are questions that everyone will have to answer individually, but I don't really have the stomach for seeding 2 inches down. It kind of scares the heck out of me, sorry. So another question is, and this kind of relates back to the first one, how far down to moist soil? If you're planning on going 2 inches deep, is the seed going to be sitting in moisture? Is it going to be above it? And also, what's the soil temperature at the intended seeding depth? Because usually when we're checking soil temperature, we're looking a lot more shallow. So if you're seeding 2 inches deep, it's a little colder. If it's super dry as we're scared it might be in some areas, how cold is it, and how stressed is that seed going to be? Sitting there cold, maybe not as wet as you think it would be, trying to fight its way up through dry soil. I don't know, another thing to consider before you pull the trigger on that 2 inch depth. And also another thing that some growers in my territory have had luck with is playing with packing pressures. So in really dry conditions, adding a little more packing pressure can help optimize that seed to soil contact and get the seed to sort of take up a little bit of that moisture that's there. Additionally, one last thing in my long diatribe about seeding to moisture is the weather forecast. In our 17 to 2019 years, it seemed like there was always rain 6 days, 5 days in the forecast, and every day it would just push a day later. And so the reality is, when we're talking about seeding canola, it is April 8th. So we still have a good month before we really need to be getting excited about seeding canola, or at least 3 weeks. So there's time for rain. There's a lot of other things that you can do instead of panicking about dry conditions. When it comes time to seed canola, make sure you're down in every field looking and checking for moisture. There's a great Canola Watch article that just came out yesterday talking about the things that you can do while you're waiting or before you seed canola. So there's other things you can do. And this is sort of, I guess, the picture that hopefully you'll scare some folks a little bit. This was a field in my territory in 2018. 2018, we had a lot of herbicide carryover issues in southern Alberta. And this particular field was seeded about 2 inches deep. It was extremely dry conditions. There was a group 2 carryover issue, and we ended up having quite a bit of seedling disease, which turned into brown girdling root rot. So when it comes to canola establishment, 1 + 1 can often equal 3. And in this case, we've got 1 + 1 + 1 + 1 equaling, 5 or 6, or total disaster. And this field happened to be right next to the highway, which was, another negative thing. So be really cautious with chasing moisture would be my encouragement, and make sure you're aware of where that moisture is and the capacity of the seeder or planter to place the soil at depth. I'm not sure how I'm doing for time, but this is my last slide. So just a reminder, a recipe for success in canola establishment is to target 5 to 8 plants per square foot, uniform plants per square foot. Take care when seeding or planting to maximize your emergence and uniformity. Evaluate each field and submit your data to canolacounts.ca and make improvements throughout the season. That is all. I'm looking forward to question period. Thanks, guys.
Okay, let's get moving on to Larry. Autumn's kids are actually on the cover of the March Canola Digest, which hopefully you get it. If you don't, you can subscribe at canoladigest.ca. They're out there counting fields or counting plants. Anyway, last speaker is Larry Durand, and Larry operates an agronomic consulting business called Field Good Agronomics, and Larry is working out of Humboldt. He's actually from Manitoba, if people recognize that name, but he's been out there in Humboldt for 20 years or so. And he'll talk about how he approaches flea beetle management with his farmer customers. Larry.
Thanks, Jay. Yeah, so basically what I'm going to do here, I guess I'd be kind of asked to be the cleanup act, but take all the wonderful information that the previous speakers have given us and kind of pull it all together and talk a little bit about how to use this information to really make some good management decisions at the farm level. So whether you're a farmer or if you're an agronomist working face to face, with the farmer, some of these, how do you use some of this information to make some of these decisions? So we'll go right into it. And I get my slides to advance. Here we go. So what I have here is what I call the flea beetle management cycle, the way I kind of view it. There's decisions to be made pre-seeding, at seeding time, and also post-seeding. And so I'll kind of talk about all those in those fashions. But overall, when we're thinking about flea beetles, the objective is that we can avoid having to make a foliar insecticide application. So let's talk about pre-seeding. So at this time of year, and I'll even suggest that months ago we should have been thinking about some of these items. But the first thing to do is a risk assessment. So what are important things to think about when you're assessing your risk for flea beetles? And it should be not just on a farm basis, but on a field by field basis. So we got to think about things like crop rotation, past flea beetle issues. I think everybody's had flea beetle issues in the past, so I don't know that that's big issue, but also consider what flea beetle species that you've had problems with, and what weather conditions have been, or what you think they might be like, and how that might impact. And of these risk components, I would suggest that probably your crop rotation and the species of flea beetles you've been experiencing are probably the two most important factors when you're assessing how much risk you think you're going to have of flea beetles in any one particular field. So this is just some information here, some crop rotation information from one of my customers, and I've blotted out their name and their actual field names just for anonymity perspectives. But so this is actually a bigger farmer client of mine. They farm about 20,000 acres, and they tend to grow a lot of canola. In fact, usually about 60% of their acres is canola. So of course, it's physically impossible to grow 60% canola without having some canola on canola. And if you look at these top two fields on the rotation, so the first field here, you kind of have your canola, cereal, canola rotation, which here around Humboldt is very, very typical. We're at more northern latitudes, so crops like soybeans and some other corn and things like that are tougher to grow successfully year after year. So canola tends to be every second year. But if you look at this second field here, they had some quinoa in 17, but after that it was canola, wheat, canola, and they're planting canola again this year. So it's going to be canola on canola. In fact, it's going to be 3 out of the last 4 years is going to be canola. So I would call this field definitely a high risk field. And even this field, I would probably call it a low to even moderate risk. So that's about, what we should be doing at this time of year as far as risk assessment. And then we need to decide at this time of year, in fact, probably this decision should have been made a few months ago, what seed you're going to buy, and more importantly, what seed treatment. So you need to buy that seed variety / treatment combination to match the risk you have on some of these fields. And it's important to note that not all seed treatments are available on all varieties. And it's important to understand the differences between the different seed treatments, which ones do what. I think most of you out there probably have a pretty good handle, but you know, I'm going to go through it here. And Keith went through this, presented this information quite well. I'm going to present it a little bit differently for my demonstration purposes, but you know, this Helix, Vibrance, and Prosper Evergold, that's kind of your base treatments, as Keith mentioned, good fungicide components. But I'm just going to talk about the insecticide components of these treatments. So, you know, these are the insecticide components. All of these products are really good on the crucifer flea beetles. Here in Humboldt, we've got just about all striped flea beetles. In fact, I think if I'd ever find a crucifer flea beetle, I would capture it and donate it to the museum. That's how rare they are here now. Like it's getting so. For me, I really want to establish how well these are going to perform against the striped flea beetles. And I've rated these poor. I'm probably being a little bit harsh. They do have activity on striped flea beetles, but if you're going to have a striped flea beetle problem, you know, they are going to fail. Then we get into kind of the next level here, the Fortenza Lumiderm, which do have the same active, but Lumiderm is at a higher rate. And I have seen Lumiderm, you know, do a fair job on striped flea beetles. But, you know, if you're going to have a real problem, you're still going to have an issue with Lumiderm trying to keep up with it. I would say for Fortenza Lumiderm, they are really a cutworm product as opposed to a flea beetle products. And but you know, when you're looking at what you're going to add to your Helix or your Prosper, if you're looking to get striped flea beetle activity, that's where you get your Fortenza Advanced. Again, it's the same as Fortenza, but they've added the sulfoxaflor, which is for those of you who are familiar with Visivio. Instead of Visivio now, I don't think you can get it by itself. It's that component has now been added with the Fortenza. So now you have a product here that you can get activity on both your cutworms and your striped flea beetles. And of course, as Keith had mentioned, new product by Bayer called Buteo Start, and it's purported to have very good activity on both the crucifer and striped flea beetle activity. I haven't seen this in the field yet, but I look forward to seeing it. So basically what you want to do, you want to think back to those fields that you've assigned as being a high risk field. So that field number 2 that I showed in the previous slide, and maybe where you're going to purchase these extra treatments, maybe put those on those fields that are going to have higher risk. So that's how you want to sit down with your farmer clients, or if you're a farmer, you pay extra maybe on just some of the fields where you think you're going to have the higher risk. Seeding management, you know, Autumn just did a great job of talking about this, but from a flea beetle standpoint, basically what we're talking about here is cultural control strategies, and it's all about getting that crop up and growing quickly. Seeding date, of course, the earlier you seed, the slower it's going to take to come out of the ground. And John mentioned, you know, you got that 3 or 4 weeks of effectiveness of these seed treatments. So if you can't get to that 3 to 4 leaves in those first 3 or 4 weeks, you're going to come and run into trouble. Seeding depth, seeding rate, you know, Autumn did a great job to talk about that. On this note, I put a little note here, pre-seed. If you think you're going to be in a high risk, and so you think you want to increase your seeding rate by ½ pound or a pound per acre, you need to make that decision before you're in the field seeding, because you need to have that extra seed. So if you got a half section of canola that you decide you want to increase your seeding rate, you need to have purchased that an extra 160 to 320 pounds of seed to accommodate for that decision. And then again, any practices that are conducive to quick crop emergence. So again, good phosphorus fertility management, good seed bed preparation, good seed to soil contact. Those are all really important to help manage that flea beetle. And then once, again, we're moving now into post-seeding, scout, scout, scout. This is a picture of my work boots. I don't know, when you're thinking, when you're looking at this, you're probably thinking one of 2 things. Is that, wow, Larry scouts a lot of fields? Or you're thinking that, wow, Larry's really cheap and too cheap to buy himself some new work boots. Truth is, it's probably a little bit from column A and a little bit from column B. But it's important once your crop is emerging and coming up, you got to be out there lots to scout. And it's important to note with flea beetles, it's not usually going to be uniform across the field, as we've already heard. It's usually patchy. Sometimes and oftentimes it's worse on the field margins. So don't just pull up onto the approach, walk in about as far as you can spit and make an assessment there. That's not adequate. You might have it might look a lot worse there, and then as you walk in, it might not be bad, and then all you need to do is control your field margins. Or maybe your margins will be fine, and you'll have some other areas in the field that are bad, and so you really got to check everywhere, and also you got to monitor over time. So when you start seeing issues, and Keith had mentioned this, it might not look that bad today, but in a few days it might be worse. So drop a pin on your phone or put flags if that's works better for you, but to monitor those patches, go back every couple of days to check that. So your scouting should be, spatial scouting and temporal scouting, and both those two are very important to keep on top of those flea beetle issues. And follow those established economic thresholds. Keith said this really well. We know what, that 25% defoliation. I just put page 613 of the Saskatchewan Guide to Crop Protection. There's pictures of percent defoliation. If you carry that book around with you, that's a good spot. I'm sure the Manitoba Guide and the Alberta Blue Book have similar pictures. Stem feeding, again, that's a different animal when you're just trying to determine thresholds. So you kind of got to go by experience. You got to go by feel if you're getting some stem feeding. But also, it's not just about the percent defoliation, the amount of damage. Consider what's your canola doing. Is your canola growing really well, really aggressively? Is it getting close to that 3 or 4 leaf stage that it might outgrow it? And so give it a chance. Or on the flip side, are you having some issues with emergence for whatever reason? Maybe you've come across some frost, maybe that's made you lose plants and slowed down the progress. And so then sometimes, just based on how your canola is doing, you might want to massage that economic threshold a little bit. And that comes with some experience and a lot of scouting and going out regularly to monitor how things are progressing. And again, if you can avoid spraying, we have a lot of friends out there. I'll encourage you to go to the Field Heroes website. Think beneficials before you spray. Lots of really good resources there about beneficial insects, whether they're pollinators or just insects that are predators of insect pests. And if you do have to spray, I know that manufacturers of the seed treatments will provide free product. Often it's 50% of your insecticide, your foliar insecticide, if you need to spray. I have known farmers and even agronomists who have taken that to mean that, oh, well, then I could justify spraying at less than 25% defoliation because my chemical is cheaper. And do not look at it that way. We want to save our friends in the field, our field heroes. So make sure you're still following those thresholds. Finally, last resort, if you do have to do a foliar spray, spot spray if it's feasible, if it is just in field margins or areas that are easy to delineate, do that. Water is your friend. You want to get coverage, so use at least 10 gallons of water. Avoid the heat of the day. And if you're going to have to go out to spray, check if there's any other insects out there as well. If cutworms were mentioned earlier. If you also have a cutworm problem and you don't realize it today when you go spray for flea beetles and you use a product like a Adhesius or Moderator, for example, you're not going to get the cutworm activity. And then you go back in a week and realize you got cutworms. Now you got to go spray something else. Now you're hitting 2 foliar fungicides, and that just makes it doubly bad. So make sure you're covering everything with one application if it comes to that. So that's all I have. So I guess we'll give it back to you, Jay, and I think we're ready to start the questions.
Yep. Thanks, Larry. Good. So we do have a few questions pouring in here. So thanks everybody for contributing to the Q&A. Keith has a couple of slides, Leanne and Karina, that he would like to just pop up at some point if he can address those. And I think everybody else is, all the other speakers will have their pictures put up at some point as well. Anyway, let's go right back to the beginning, because really early on in the presentation, Randy Fraze in Manitoba had a question. I think let's start, John, with this one. If you feel, this is Randy's question, John, if you feel numbers are high in the fall, is it worth spraying? And this is, so numbers are high in the fall, now it's spring. Is it worth spraying if your neighbors are not? And so Randy's wondering, and if you spray, your neighbors don't, just do all of the flea beetles move in from your neighbor's field, given that they seem to move around fairly quickly?
Yeah, as I mentioned, the correlation between the fall numbers and the spring, people have tried to measure that, to do studies on it a couple times, and the data is real messy. It's not a great correlation. You can use that as a somewhat of a guide, but again, the correlation is not great. Now, regarding if you spray, you cleaned up your field, your neighbors aren't, flea beetles are very mobile. So there is certainly that possibility that they could be moving in from your neighbor's fields. Now, whether they do move, their movement is something that needs a lot more work as well. Alejandro's doing a bit of work on that. But there's certain things that will dictate where they move to. They're probably going to go to the closest good source of food to where they've overwintered. And what often draws them in is, once you do get a little bit of feeding, there's a chemicals given off by the plant called glucosinolates that will draw them in. The flea beetles themselves produce something called an aggregation pheromone. So that means they smell the chemical released by their peers, their siblings, and they get drawn to that. So short answer is, if you do a foliar spray, you're still in the vulnerable stages, still keep an eye on it. We have seen people have to do 2 and even 3 or more sprays when flea beetles were very thick, and they are very active. So yeah, keep an eye on it. Hopefully that addresses the question.
Just a bit on the life cycle of flea beetles. So the flea beetles that emerge in the spring and early summer, that's the population. They don't cycle more than once a year, right?
They have 1 generation per year. So there's a set number of flea beetles overwintering right now. We can't have any more than that in May and June. That number is finite, it's set. The reproduction is going to happen. They'll be laying their eggs June, early July. Well, probably more late May and June is when most of the eggs will get laid. And then their larvae in the ground. But once that egg laying happens in June, things are set for the next cycle, the next year.
Yeah, good. Thanks, John. Okay, Ale, I'm sure you have a comment on that one, but I'm going to give this question to you. This is from Jason Vogt in Manitoba. So, and John, this alludes to something you mentioned, but I'm going to let Ale answer this one. So 15°C soil temperatures, that's when the crucifers really get going, emerge. What about stripes? Do we have some details on when striped start to emerge?
Yeah, we didn't study directly temperature and emergence of flea beetles. We observed that stripe tends to be earlier than crucifer. So that's all we know so far, but we don't have a detailed model of emergence based on temperature. What I can say is we have tried in the lab feeding at lower temperatures than 18, and it's very, very little. Now, we use constant temperature in the field. Temperature is not constant. When the sun hits, it's probably higher than the air temperature that we measure. So there's some microclimatic issues there. So they could potentially be doing feeding at lower real temperatures than what we have measured. But
so speaking of model, Just to follow up on that, Ali, Jason also asked about growing degree days and modeling. Do we have any number of growing degree days where we can start to predict when the flea beetles come out? John, you can jump in here too if you want.
As far as I know, there's no growing degree day models that we can use. The work just hasn't been done really for that. We chronologically know roughly when flea beetles will be coming out. Stripes usually a bit earlier, starting almost right now. Crucifer a bit later, but no, we don't have a growing degree day model like we do for, say, grasshoppers or Bertha armyworm that we can follow and predict things the way we do with other insects.
Ali, anything to add there?
No, I agree.
Oh,
we don't have
okay.
a model, and it's very hard to predict where they're moving. Just for the previous question, we don't know how far they move, really. And the studies we are doing give us probably the only way we have, which is indirect, to assess that. So if we found that they are responding to things that are within 2 kilometers, that's what we normally use for these and other insects to gauge how far they move, right? For things that affect them within a smaller scale, that indicates they are really moving within that scale. So as far as we know now, they could move up, respond to things that are within 2 kilometers distance. So yeah, so that's all I think I can say about movement at this point.
Tyler Wist, entomologist, research scientist with Ag Canada in Saskatoon, he just added in the chat here that Stripe will be out on the first warm days in spring, and Stripe will be out about 2 weeks before crucifer. So that's based on his work, his experience. And I'm assuming that if people are seeing flea beetles out there right now, they're probably striped. Anyway, let's move on to a couple of weather-related flea beetle management questions. So Curtis McRae in Manitoba asks, okay, so this is how quick the damage can escalate. So I don't know who wants to take this one, but Curtis asks, when damage reaches 25% in the morning, how fast can it blow up to by the end of the day? Could you get to 50 by the end of the day? Alejandro, you're nodding. Why don't you take this one?
I shouldn't have not. We don't know, but all I can say is we try to do our experiments sampling 3 times a week, and sometimes it's not enough. But I don't have real data on that. But we will go on Monday, and it might be 10%. We will go on Wednesday, and maybe 50%. So I don't know how fast it happened, but within the 2 days, it can happen very quickly.
John, before we go to you, let's see if Keith, Autumn, or Larry have a comment. You guys, have any of
my
you...
comment in the chat? In as little as a day, I've heard from a number of people. I can't say I've ever seen that happen myself. On small plots where there's not a lot of canola around, yes, I think I'd give you that in as little as a day. Where I see that change happening that quickly is often if you haven't done a really good job of scouting. And if you don't mark, Larry mentioned putting flags in the field, and that's actually pretty important, because if you go to a different spot in the field, even if it's 25, 30 feet away, and if you haven't actually got a good feel for the entire field, you could easily get the impression that your feeding damage has gone up 25%. So it's the amount of scouting that you're doing and the frequency of scouting. The more you're scared, the more often you should be in there. And if you're in the unfortunate situation where a foliar insecticide is going to be required, you'll probably have the feeling like, why didn't I just pull the trigger and make that decision earlier? But it's a drawn out procedure to make that decision and decide if it's needed. So there's no right answer. I'll pass it off.
Well, and I guess the key there is that if you're at 25% in the morning and it seems like a good day for feeding, you might as well. I mean, that's the action threshold, right? So if we're working towards any number, 35, 45, 50 or more, that sounds like a time to spray. John?
Yeah, I was just going to mention there's really 3 environmental factors that will determine how quickly that feeding progresses. So it's going to depend on the day and what it's like. Humidity is one of them. We know that they feed more on drier days than on more humid days. Wind speed, they don't like it too windy. So if it's calm and dry, they will do more feeding. And also temperature, Alejandro alluded to that. Hot, dry, calm, that's when you're going to get your maximum feeding. On a hot, dry, calm day in late May, early June, you can easily go from 25 to 50 or more in a day. If it's damp or windy, cool, less likely. So those hot, dry, calm days, really scout your fields carefully, especially if it's been that 3 weeks. And just anecdotally, when I was doing flea beetle variety work in Alberta, we were trying to entice flea beetles to feed on our plants to get damage. And we noticed that when the humidity was too high, they just weren't feeding as much. So that can be quite noticeable. And obviously the temperature thing, Alejandro alluded to that.
So Jason actually had a follow-up to that, John. Well, he asked it a long time ago, but it fits in with what you were just saying on wind speed. So with higher winds, will the flea beetles go down and feed on the stem, or does their activity just drop off?
I think Alejandro is actually studying that. So he's probably a better one to answer. We don't know, but we suspect that's probably what happens, is that on a windier day, they're staying in the cracks in the soil, or they're staying lower on the plant and doing more feeding. But no one's really, I don't think, confirmed it, but I think Alejandro might have been doing some work on that. Is that correct, Alejandro?
We're trying. It's a lot more difficult than we thought to manipulate the wind in a good way. But that's part of what Shayla is trying to do in the lab. Is we start with temperature because essentially we couldn't do the wind part yet, but we're trying to test whether cold and windy conditions cause more stem damage. So we're developing also a way to efficiently measure stem damage, which is a big hindrance in this kind of research. So we're close to get that and see if we can get more data on that.
So we've only got 4 minutes left, and we've got a few questions. We've got some stand establishment questions, which we'll try to get to. But Leanne, if you can pop up Keith's slide, Keith, if you still want to show that. And then while you're doing that, there is a few questions related to the insecticide. Is there any chance of crucifer or striped becoming resistant to a particular insecticide group? Is that a risk? That's if anybody knows.
Who is going to answer that? We haven't seen that. We haven't really seen that as a concern. We do see it's possible with any insect. John's probably the best person to answer this. Much more concerned about diamondback moths blowing in with insecticide resistance than I am flea beetles, but I guess it's a possibility. I don't know if it's a real threat at the moment.
Okay, good. Keith, you might as well just keep talking. Go.
And the one thing that we didn't really call attention to, but you could have heard in the news in the last week or 10 days, is that our industry is really happy that we've been allowed continued use of neonicotinoid seed treatments. That's been under pressure for us. We've worked diligently with the PMRA to provide some data and to answer any questions that they might have. And we're really pleased that the ability to continue to use neonics has been preserved for us. You've seen that announcement in the news, so I just thought I'd call that to your attention. So we've been adding seed treatments to the market, but the neonics have been a pretty solid tool for us, and we're happy to see that continues, and should give ourselves a pat on the back to continue to keep this tool available for customers.
Okay, can we go on to a couple of quick questions on stand establishment?
Go for it.
Okay, so Autumn, Frank Bergen asks about how deep to seed if you're in dry soils.
Yeah, so I think the reality is you have to know what's in your field. So should you plan to seed everything at a 1/2 inch when it's dry powder? Probably not. If rain is 90% chance coming tonight, then you could to take advantage of it. The deepest that I would feel comfortable making a recommendation to seed would probably be 1.25 inches, 1.5 inches, and that just it scares me because I know that placing seed that deep does not mean every seed is going that deep. And so if you've got an operator and a piece of equipment that you are confident is going to be laser precise, placing every single seed at that depth, really it's a matter of, you know, how much risk the grower is able to tolerate. But I get a little nervous when everybody jumps to that 2 inches. And I think the important part is going out and checking what's there, because if you're going 2 inches down and you're not going to be in soil moisture at 2 inches down, I don't know, I'd argue that's just adding unnecessary stress. But I'm interested in Larry's experience on this as well, because he's been around a little longer than I have.
I'd answer it a little different.
That's a nice way to say it.
Let's go to Larry.
Yep.
Yeah, the experience I've had actually is been a bit mixed. I have had customers that we went through like 10 years of really wet weather, and so just encouraging guys to seed shallow enough was often a challenge. And now we've turned back into dry, and some guys have got into that habit of seeding that, you know, half inch, even, you know, when you do that, you're at that 1/4 inch. And what I've noticed is that some guys want to seed just to the moisture, just on top of the moisture. And what sometimes happens is that if you do that and then you go through a dry spell, so you're just on the moisture, so you have enough moisture for that seed to imbibe the moisture and get going. And if you don't get any rain, that seedling just withers and dies. Whereas if you seed it into the dust, then it's just going to sit there. And then once you get a rain, a good rain, it'll imbibe, it'll start growing, and it'll survive. So you want to seed, if you've got some moisture at about 1 inch, and I wouldn't, like Autumn says, I wouldn't want to go much more than 1.25 inches or 1.5 inches. But if you're going to go that deep, make sure there's good moisture there. Because if you're going that deep just on top of the moisture and there's no rain in the forecast, you can end up with a world of hurt.
Okay, we're at time, and we have one more quick question for Autumn, and then I'm going to give Keith a chance to just wrap up for 30 seconds, Keith. So we'll do Autumn first, and then Keith, I want you to wrap up with what you want, the key take-home message, a 30-second wrap up for us. So Autumn, just a question from Wade Stalker, and you touched on this, but I think just to really emphasize the point of volunteers when you're doing a plant count, and making sure to isolate them as best as you can, because they shouldn't be counted. What would you say?
Yeah, no, I think that's a really important question. Glad to highlight it again. So one technique is, especially if you're switching herbicide systems of your canola, is to wait until after your herbicide application to do your counts. If your emergence is really high, so another benefit of doing your emergence counts every year, if you're getting 100 or 90 or over 100% emergence, then obviously you're counting volunteers, especially if you're over 100. So go back and make sure you're positive that that the numbers, that the plants that you're getting are not volunteers. You can look and physically look for seed coats. The blue seed coats are, you know, can be pretty easy to find at that seedling stage, 2 to 4 leaf. And then some things are kind of obvious, like sometimes volunteers will be bigger than the stuff in the seed row. But really anything you can do to make sure you're not counting them. And obviously, I mean, something we can do to minimize volunteers is stretch out canola rotations, which is something a lot of us could be working on as well.
Good, thanks, Autumn. Okay, Keith, last word to you, and then I'll sign off, and Karina will wrap things up for us. Keith.
Well, if I had to summarize it, I would probably go back to seeding is the one chance that you're going to have to set your crop up for success. So do a good job of it. The best investment you can put in your field is a scouting shadow, and checking your depth in one spot on one row is really not enough. And it might be funny that I'm talking about seeding when the whole webinar's been about flea beetles. But my experience with flea beetles is that it's kind of like baseball. You're not out on one strike. If you do a poor job of seeding and then it gets hot and dry, and then you realize that you have high populations, flea beetles will take over and damage your crops. So get out there, do a good job, set yourself up for success, and continue scouting throughout the whole season, Jay.
Great, thanks, Keith. Karina.
Well, I just want to say thank you, Jay, for moderating this morning, and to all our panelists for an awesome presentation. It seemed jam-packed for the whole hour and a half. So thank you very much. And I hope everybody that joined us today feels a little bit more armed to handle flea beetles this spring. And so I think we'll sign off. I hope everybody has a really good day. Thank you, everybody.